Hello everyone. In this video, we will talk about loop structure in the data step. A loop is a basic logical programming concept, where one or more statements are executed repetitively, until a predefined condition is satisfied. An implicit loop, which was introduced in Chapter 3, results when the data step repetitively reads data values from the input data set, executes statements, and creates observations one at a time. SAS stops reading the input data when it reaches the end of file marker, which is located at the end of the input data file. At this point, the implicit loop ends. Suppose that we would like to assign each subject, in a group of patients in a clinical trial, where each patient has a 50% chance of receiving either the drug, or a placebo. For illustration purposes, only 4 patients from the trial are used in this example. To assign a patient with either a drug, or a placebo group, we can use the ranUni function. The ranUni function is used to generate a random number that follows uniform distribution between 0 and 1. The seed in the ranUni function is a non-negative integer. The function generates a stream of numbers based on seed. When the seed value is set to 0, which is the computer clock, the generated number cannot be reproduced. However, when the seed is a non-zero number, the generated number can be reproduced. This program reads data by using the set statement. Then the group variable is assigned with either D for drug, or P for placebo, based on the randomly generated number. Let's use the program to review the implicit loop. At the beginning of the data step execution phase, _n_ is initialized to 1, _error_ is set to 0, and the rest of the variables are set to missing. The set statement copies the first observation from the input data to the PDV. Ran_nom is assigned with a value that is generated from the ranUni function. Since this generated number is not greater than 0.5, the group variable is assigned with P. At the end of the data step, the implicit output copies the variables that are marked with K in the PDV to the output data set. Then SAS returns to the beginning of the data step. At the beginning of the second iteration, _n_ is incremented to 2. ID is retained, since ID is from the input data set. Group and ran_nom is set to missing. The set statement copies the second observation from the input data to the PDV. Let's skip a few iterations. At the end of the fourth iteration, the implicit output generates the fourth observation. SAS again returns to the beginning of the data step. At the beginning of the fifth iteration, _n_ is incremented to 5. SAS reaches the end of the file marker, which means there are no more observations to read. The execution phase is completed, and SAS goes to the next data or proc step. In the previous example, the patient ID is stored in an input dataset. Suppose we don't have a dataset containing patient IDs. We are asked to assign 4 patients, with a 50% chance of receiving either the drug, or the placebo. Instead of creating an input dataset that stores ID, we can create the ID, and assign each ID to a group at the same time. Here's the program to assign each ID to a group in the data step, without reading ID from an input dataset. In this program, we need to assign ID with ID values 4 times, then assigns the group value based on a generated random number. There are 4 explicit output statements that tell SAS to write the current observation from the PDV to the SAS dataset immediately, not at the end of the data step. However, without using the explicit output statement, we will only create one observation for ID equals M1240. Notice that most of the statements in this program are identical. To reduce the amount of coding, we can simply rewrite the program by placing repetitive statements in a do loop. In the iterative do loop, we must specify an index variable that contains the value of the current iteration. The loop will execute along value 1 through value n, and the values can be either character or numeric. Now, we can rewrite the previous program by using an iterative do loop. We will use ID as the index variable. These 4 ID values are the value 1 to value 4 that need to be specified after the equal sign in the do statement. These 4 SAS statements are identical and need to be placed within the loop. The program on the right side utilizes an iterative do loop to simplify the previous program. More of the time, we use an iterative do loop to iterate along a sequence of integers. The loop will execute from the start value to the stop value. The optional by clause specifies an increment between start and stop. The default value for the increment is 1. Start, stop, and increment can be numbers, variables, or SAS expressions. These values are set upon entry into the do loop, and cannot be modified during the processing of the do loop. However, the index variable can be changed within the loop. Suppose that we are using a numeric sequence, say 1 to 4, as patient IDs. We can rewrite the previous program as the one on this slide. This program uses ID as the index variable. The start value is 1, and the stop value is 4. We didn't specify the increment value, since the default value is 1. Let's go through the data step execution phase, to understand this loop better. Since we didn't read any input data set, there will be only one iteration for the data step. _n_ will be 1 for the entire execution phase. At the beginning of the first iteration of the do loop, ID is assigned with value 1. Random is generated. Since random is not greater than 0.5, group is assigned with p. The output statement copies the variables marked with k in the PDV to the output dataset. SAS reaches the end of the do loop and returns to the beginning of the do loop to start the next iteration. At the beginning of the second iteration, ID is incremented to 2. Since 2 is less than or equal to 4, the second iteration continues. Random is generated again. Since random is greater than 0.5, group is assigned with value d. The output statement copies the contents from PDV to the output data. Let's skip 2 iterations. Here's the content in the PDV at the end of the 4th iteration. We have 4 observations generated. SAS returns to the beginning of the loop to start the next iteration. At the beginning of the 5th iteration, ID is incremented to 5. Since 5 is greater than 4, the loop ends. There will be no implicit upshot, since the explicit output statement is used in the data step. Since we didn't read any input dataset, the data step execution ends at this point. Using an iterative do loop requires that we specify the number of iterations for the do loop. Sometimes, however, we will need to execute statements repetitively until a condition is met. In this situation, we need to use either the do while or do until statements. In the do while loop, the expression is evaluated at the top of the do loop. The do loop will not execute if the expression is evaluated to be false. We can rewrite the previous program by using a do while loop. In the do while loop, we need to specify a condition to control when the loop will stop. In this program, we compare ID variable with value 4 as the condition for stopping the loop. ID variable is created by using the sum statement within the loop. Let's go through the data step execution phase. At the beginning of the data step execution, _n_ is initialized to 1. ID is set to 0, because ID is created by using the sum statement. The rest of the variables are set to missing. Since ID is 0, which is less than 4, the loop continues. ID is incremented to 1. Random is generated. Since random is less than 0.5, the group variable is assigned with value p. The output statement copies the variables that marked with k in the PDV to the output dataset. SAS reaches the end of the do while loop and returns to the beginning of loop to start the next iteration. Since ID equals to 1, which is less than 4, the loop continues. ID is incremented to 2. Let's skip a few iterations. Here are the contents of the PDV at the end of the 4th iteration. At this point, ID equals to 4. There are 4 observations being generated. SAS returns to the beginning of the data step to begin the 5th iteration. However, ID is not less than 4, the loop stops. SAS reaches the end of the data step, the execution phase ends. We can also use the do until loop to execute the statements conditionally. Unlike do while loops, the do until loop evaluates the condition at the end of the loop. The do until loop will not continue for another iteration if the expression is evaluated to be true at the end of the current loop. That means the do until loop always executes at least once. We can rewrite this program by using the do until loop. Let's compare the differences between using the do while loop and the do until loop. When using the do while loop, the loop will not continue if the expression is evaluated to be false. The condition of the expression is evaluated at the top of the loop. On the other hand, the condition of the expression is evaluated at the bottom of the do until loop. The loop will not continue for another iteration if the expression is evaluated to be true. A common application for using loops is placing a loop within another loop. To continue with the previous example, suppose that we would like to assign 12 subjects from 3 cancer centers, with 4 subjects per center, where each patient has a 50% chance of receiving either the drug or a placebo. A nested loop can be used to solve this problem. In the outer loop, the index variable, center, is assigned to the values with the name of the 3 cancer centers. For each iteration of the outer loop, there is an inner loop that is used to assign each patient to a group. Since the outer loop iterates 3 times, and the inner loop iterates 4 times, placing the output statement inside the inner loop will generate 12 observations. In the previous examples, all the observations were created from one data step, since the data step didn't read in any input data. The center variable gets its value from an outer loop. Sometimes it is necessary to use an explicit loop to create multiple observations for each observation that is read from an input dataset. For example, suppose the values for center are stored in a SAS dataset. For each center, we need to assign 4 patients, where each patient has a 50% chance of receiving either the drug or a placebo. In this situation, we need to read the value for the center variable via the implicit loop. Then for each center that is being read into the PDV, we need to utilize an explicit loop to create the ID and group variables. Now, let's review what we've learned from this video. In this video, we compared the implicit and explicit loops. The implicit loop refers to the data step repetitively reading data values, executing statements, and creating observations one at a time. The explicit loop utilizes do while, or do until statements to execute statements repetitively. To use an iterative do loop, we need to know the number of times the loop iterates. To use a do while, or a do until loop, we need to use a condition to control when the loop ends. Utilizing an explicit loop is commonly used together with array processing, which we will learn in the next chapter. I hope you enjoyed this video. Please subscribe to my channel and click the bell icon to get new video updates.